This is solving equations using square roots. When we're solving a problem like x squared equals d, and the d value is greater than 0, the x squared equals d problem is going to have two solutions. And they're going to be the positive square root of d and the negative square root of d. If d is exactly equal to 0, we're going to have one real solution, and that solution is 0. If d is less than 0, we're going to have no real solutions. So let's see this in action by looking at some examples. So let's try solving some quadratic equations using square roots. So I'm trying to solve for x, basically. So here I would add 27 to both sides. So I'm going to have 3x squared equals 27. And then to get x by itself, I'm going to divide each side by 3. So I'm going to get x squared equals 9. And now to get rid of the squared, I'm going to do the square root of each side. So the square root of 9 can be positive 3, 3 times 3 equals 9, or negative 3, because negative 3 times negative 3 will also give you 9. So we have two solutions for x here, positive 3 and negative 3. In this case, I'm going to start by adding 10 to each side, so I'm getting x squared equals 0. Now if I square root each side here, the square root of 0 is 0, so I'm only going to get one solution. In this case, if I subtract 11 from each side, I'm going to get negative 5x squared equals 5. And now if I divide each side by negative 5, I get x squared equals negative 1. Now there's no way for a squared number to give us a negative solution here. So there are no values of x that are going to work here. So we have no solution. Let's take a look at another problem that we're going to solve using square roots. So x minus 1, the entire quantity squared, equals 25. So the first thing that I want to do to solve this problem is square root each side. And when I square root 25, I can either have positive 5, because 5 times 5 is 25, or negative 5. So x minus 1 here can equal positive 5 or negative 5. So I can actually break this into two problems. So if I have x minus 1 equals 5, my solution here is going to be x equals 6. But remember, x minus 1 can also equal negative 5, in which case our solution would be negative 4. So x equals negative 4 and x equals 6 are both solutions for x in this quadratic equation. Let's try approximating solutions of quadratic equations. So in this case, we have the problem 4x squared minus 13 equals 15. So the first thing I'm going to do is add 13 to each side. So I get 4x squared equals 28. Divide each side by 4, and I get x squared equals 7. So now I'm going to do the square root of x squared and the square root of 7. So x will have to be the positive or negative answer to the square root of 7. Now this is where my calculator is going to come in handy. They're saying I should round my answer to the nearest hundredth. So when I put this in my calculator, the square root of 7 to the nearest hundredth, I get 2.65. So x can be positive 2.65 or negative 2.65. Let's look at a real life problem. Here we have a touch tank that is 3 feet tall. Its length is 3 times its width, and they want us to find the volume of the tank. They want us to find the length and the width. The volume of the tank is 270 cubic feet, so we're looking for that length and width value. So the normal formula that we use for volume of any type of rectangular prism is length times width times height equals our volume. Well, in this case, the length is 3 times our width. The width is just the width, and the height is 3. and it equals 270 cubic feet. So if we're going to combine this here, we're going to get 9w squared equals 270. So I'm going to divide each side by 9, and I get w squared equals 30. So now I have to do the square root of each side in order to find the positive or negative square root of 30. And our answer is going to be approximately 5.5 feet. Now in this case, I'm going to ignore the negative value because I know that when I'm talking about a touch tank, that a width can't be negative 5.5 feet. So I'm going to exclude that answer. It's got to be the positive answer. So the width here is 5.5 feet. Now the length was about 3 of those. So for the length, we're going to have to do 3 times 5.5. So for the length, we get about 16.5 feet. Let's take a look at one more problem. Rearranging and evaluating a formula. So the area of this equilateral triangle sign here with a side length of s is given by the formula a equals the square root of 3 over 4 times s squared. We want to solve the formula for s. After we do that, we're going to approximate the side length of a traffic sign that has an area of 390 inches squared. So let's just start by taking a look at the formula. So let's say we want to solve this formula for s, so we can just plug in areas and find our side length. So the first thing I would do here is I would multiply both sides by the reciprocal of the square root of 3 over 4. So it's kind of like dividing by the square root of 3 over 4 and multiplying by the reciprocal. So I'm going to multiply by 4 over square root 3. So here I'm multiplying by 4 over square root 3. And this will cancel out. Now I need to do the square root of each side to cancel out the squared here with my side. So s equals the square root of 4 times a over the square root of 3. So now we're going to plug in an area of 390 inches squared. So if the sign has this area, what's the side length? So we're going to plug in 390 for our area. So 4 times 390 over the square root of 3. So 4 times 390 is going to give us a total of 1,560. And now I'm going to use my calculator here to do the 1,560 divided by the square root of 3, and then do the square root of that whole answer. And for my side length, I get 30. So a side length is about 30 inches for this equilateral triangle.